Good day, wonderful mindsetters. My name is Tara, and we are here today for some beautiful geography. I'm in studio with Kamala, and how are you today?
Ta-dam, ta-da! Hi guys, welcome. Geography Grade 10. Excellent show. We're going to do all those calculations and get you ready for your exams. Back to you, Tara.
So we've got plenty to do grade 10s, and it's going to be a fun bit with us. But before we get started, there's a couple of things I want to remind you about. As you know, we have this awesome competition running, but there's only going for 2 more days. It's called the Be a Bright Spark. And by entering, you stand a chance to win a Chevy Spark. Now, a lot of you in the process of, looking into getting your learners. So I would strongly suggest for you guys to purchase this Safeways K53 Learners and Drivers Manual to help you in preparation for the test. But by buying this, and using your receipt, you can enter a competition to win the Chevy Spark. But you can also do so by downloading the app. But you mustn't be concerned. It's not only through credit card, which is, as some of you may have thought. What is also possible is for you to go down to your closest Pick and Pay store, get a voucher and redeem that as your purchase using that voucher, and then there is your downloaded app. So it's just as easy, great both ways, and an awesome way for you to start preparing for your learners, which is such an exciting part which you guys are going to get into. So there's only 2 more days left if you want to enter this competition, so definitely do so. One last thing from me, this is proudly brought to you by the MTN SA Foundation and endorsed by the Department of Basic Education. Let's go, Kamala.
Thanks, Tara. What a sparkling personality. Guys, get those entries in. I want to see one of you driving those cars. Anyway, back to today. Geography Grade 10, Mapwork skills. That's our focus today, and you've got to ensure you've got a topographic map in front of you, a ruler, a protractor, a calculator, and a pencil, so you can get with it. Today's lesson, we're going to touch on aspects that you should be expecting in your paper 2. Let's have a closer look. In today's lesson, we will be discussing point number 1, locating exact position in terms of degrees, minutes, and seconds. Now, guys, remember, this can also be expressed as grid reference, as well as coordinates. This is a common area of testing in grade 10 geography paper 2. You've got to be able to locate specific positions on the map, and to do this you've got to be able to calculate them. Further on, we will also be looking at scale. Remember, there are 3 types of scales: a word scale, a ratio scale, and a line scale. We'll be looking at direction and specifically magnetic declination. And while doing that, we're also going to be calculating the distance, measuring and converting ground distances along a straight line. These are but a few of the calculations that we will touch on. We will also look closely at some interpretive types of questions to get you ready and prepared. So without further ado, let's get into our first calculation, which is area. But before we begin, like this show, and thank you, Macmillan, we've got a challenge question for you. Throughout the grade 10, 11, and 12, we've been working with topographic maps. My question to you guys, how many topographic maps are there to cover the entire mapped area of South Africa? How many topographic maps cover the entire mapped area of South Africa? It requires you to do some research, but I'm sure you're going to get the answer by the end of the show. So let's move on to that area calculation. The first one, before we begin, is going to look at a summary of the expectations for these calculations, especially looking at coordinates, magnetic declination, and area. What I will be doing now is giving you a brief overview of the expectations. Let's look at position. In terms of that, I've drawn the following diagram, and I'm going to extend the page for you so that you can see exactly what we're looking at. Remember, these blocks, block A, B, C, and D, is a grid reference point on a map. When we further subdivide these blocks, we get A, B, C, D. This little block, or any other block, covers a 1:50,000 topographic map. And remember, we are guided by the latitudes and longitudes. So today's lesson deals with the 25th parallel or latitude, which is 25 degrees south of the equator, followed by the 26th latitude south of the equator. Further on, we look at the longitudes, 27 degrees east of the Greenwich Meridian, 28 degrees east of the Greenwich Meridian. Each block then represents 1:50,000 maps. Remember, it takes 4 blocks to get an entire mapped area. So the question relates to, in terms of this, if one small block, which in this case is block CA, is a 1:50,000 map, how many of these maps will be required to cover the entire mapped area of South Africa? Let's do a quick explanation of magnetic declination. In terms of declination, remember, we are constantly using topographic maps with a scale of 1:50,000. All the information required for magnetic declination is found in the marginal areas of the map. Remember your full calculation. Magnetic bearing is equal to true bearing plus magnetic declination. Why do we calculate this? Remember, in terms of the globe, the Earth has 2 norths, a true north and a magnetic north, due to the evolutionary forces of rotation and revolution and the magnetic North Pole versus the true North Pole. So, what does this simply mean? Any position on the Earth has 2 north directions, a magnetic north and a true north. The north on a map is straight up. Remember, that position is not really north. We calculate the magnetic declination and bearing in order to calculate your position in relation to the magnetic north. Let's look at the marginal information that you would find on the map. So, remember, that marginal information is as follows. The mean magnetic declination, which is 20 degrees and 35 minutes west of true north. We will always be west of the true north in terms of our position in South Africa. Further on, the mean annual change, which helps us do the calculation, and in this case, it is 6 minutes westwards. Now, the golden rule, guys, and you should not forget this, is that when the mean annual change is east, we will always subtract in our magnetic declination. When the mean annual change is west, we will always add in the mean annual declination. That's the golden rule that you have to remember in your calculation, which we will do later on in the show. Let's go further. I want you to always remember that when we are calculating years, the year immediately after the mean magnetic declination is the one that is used. In this case, 2001. Always discard the year immediately after the mean annual change. It is not used. Many of you sometimes confuse the years. I want you to remember this golden rule. We always use the mean annual change of the map in terms of 6 minutes westward, but not the year given immediately after. The mean magnetic declination, dependent on the west of true north, is the year given thereafter. Let's go further on. And some golden rules that you should follow. True north is shown by the vertical straight line, which in this case is that line. The magnetic north is shown by the arrow pointing to west of true north, which is this line. So immediately, guys, you should be able to see that this area here will determine the magnetic declination on a map. How do we do this? Don't forget, we are going to be able to calculate the true bearing using a protractor in order to determine the magnetic bearing on the map. Let's go further on to some helpful hints. The magnetic declination can be measured as the angle between the magnetic north and the true north. As I've indicated in the diagram, this is your magnetic declination. That angle determines the magnetic declination. Further on, the mean magnetic declination is 20 degrees, 35 minutes west of true north. In this example, the mean magnetic declination is expressed as a degree and minutes. The example that we're going to do today has not got degrees and minutes, and I will show you how we convert to degrees and minutes when the map does not show you this particular calculation. Further on, the mean annual change is 6 minutes westwards, always given on the map. And of course, as we've indicated, the year on the map was drawn as 2001. Now, these are some of the rules that you have to follow in order to determine the mean magnetic declination, the mean annual change, calculating the magnetic declination. Ultimately, you would have at this stage been able to calculate the true bearing using your protractor. When we move further on, magnetic bearing is equal to true bearing plus magnetic declination. At grade 10, you've got to be able to understand the steps and extract information in order to calculate. Don't forget, also the calculations that we're looking at today is area. Area is equal to length times breadth. Standard formulas that you've got to master, because if you've been looking at previous papers, not in all cases is the calculations given, or the formulas. So you've got to be able to master and remember those formulas in order to calculate. How are we doing, Tara?
We're going well. I have no questions, so if you have any, please feel free to ask and we can try help you out. But for now, it's all
Great.
right.
Great, thanks, Tara. And now, guys, we're going to move on straight into those calculations. The first one we'll be looking at is area. The question reads as follows. Question 1, calculate the distance between T junctions, Schoemansville and Melody. Now what we've done is taken an extract of the map. Note, we have a T junction at that point and a T junction at that point. We are required to calculate the distance between the 2 points. In order to do this, and my golden rule is always measure in millimeters when you are calculating the distance between 2 points. I'll start off with my formula. Actual distance is equal to map distance times scale. I've already calculated the distance using my ruler. Now remember, guys, when looking at a map like this, it would be from that point where the T junction is to that point where the T junction is. I would use my ruler to measure the distance of that road between the 2 junctions. So, map distance in this example was 20 millimeters. Let's put that again as 20 centimeters. Now note, I've always indicated to you that you've got to measure in millimeters, which would then give me an answer of 200 millimeters. And note, when I multiply my scale by a millimeter, it is always 0.05. When I use my scale as centimeters, I must remember that my scale is always 0.5. And in this example, using my calculator, let's clear that. In this example, 20 times 0.5 is 10 kilometers. And that would give me my answer. So, it's a simple process of measuring the distance of a straight line, in this case, the distance between 2 T junctions, and ensuring that your measurements are accurate. Note, you can measure in centimeters or millimeters. It'll all depend on what unit of measurement you are using. If you are using centimeters, you are going to multiply your distance by 0.5. If you are using millimeters, you're going to multiply your distance by 0.05, as I've shown you. And with that, guys, I think it's time for a break. What do you think, Tara?
I think so too. As you know, you can find all the links and information that you need on our Facebook page, facebook.com/learnextra. And please feel free to ask. If you have any questions, we'd love to help you make sure that you understand. But that's it for now, and we'll see you after the break. Welcome back, grade 10 learners. We've got quite a bit more to do, so I'm going to get right to it, Kamlan.
Thanks, Tara. Guys, now we're going to calculate the area using an extract of the topographical map. Let's go straight into the question. In this example, question 1, we've got 1.2. Calculate the area of B1. In this example, we've got the block B1. And note the following. This is a simple calculation which all of you should be able to calculate. It simply requires you to measure the latitudes and longitudes within the block in order to determine how much of area does it occupy. Now, normally you could get an irregular feature, but for grade 10, I'm going to say that you've got to be able to calculate regular features at this stage. But be prepared for irregular features, like, for example, excavation points, as well as areas that occupy storage dams, and in some cases, we also get golf courses. These are specifically irregular features on a map which may have to be calculated in terms of area. But for today's example, I've used a simple calculation where we will calculate the area of a block on a topographical map. Let's get straight into it. My formula, area is equal to length times breadth. I'm going to get the pink now, is equal to, when I measured my length, which is between that line of latitude and that line of latitude, I received a total distance of 37 millimeters. Note, even in this calculation, you are measuring in millimeters. So the golden rule is 0.05 is your scale, which is converted from a 1:50,000 scale. So what I measure, I must multiply. My answer would then be 0.05 for the length. Further on, then I would multiply my distance for the breadth. And in this example, let's use the yellow. I would measure the distance from that point, covering that entire line, to that point. So, in this example, I measured 31 millimeters, multiplied by 0.05, not forgetting my golden rule. With a calculator, you should be able to calculate these distances. When I calculated my distances, note, I am still measuring, and my conversion, because of this scale, becomes a kilometer scale. So I'm going to go back to the green and convert it, which is 1.85 kilometers when we calculate that. And in terms of my 31, we would get 1.25 kilometers. Now note, in this calculation, I have actually used a distance to measure, a ruler to measure the distance between the length and the breadth in a specific block. Because I've measured in millimeters, therefore my answer will be converted to kilometers because I've used a scale of 0.05. Let's move on. Once I'm able to calculate these, you should note that kilometers times kilometers will be kilometers squared. My answer, 3.25 kilometers squared. And this gives me the area of the block. This, guys, is a simple calculation which you should be able to score on as frequently as possible, especially because it is a regular feature. If the feature is asked for on an orthophotograph, therefore, you should remember that your scale on an orthophotograph is 1:10,000, which changes from the 1:50,000 topographical map. Hence, I will then be multiplying by 0.1 for centimeters and 0.01 for millimeters. I hope you've understood that calculation, guys. It's a simple calculation of area is equal to length times breadth. Let's move on. In the next calculation, we'll be looking at magnetic declination. Magnetic declination, remember, is our position in relation to the magnetic North Pole. to gather and calculate this particular example, you should be able to extract crucial information from the marginal areas outside the map. And when you extract that correct information, that will give you the answer that we require. However, there's certain steps that you need to follow, and if you listen carefully and write these steps down, they should not change at all. Let's look at the calculation. So the question is as follows. Calculate the magnetic declination for the present year. This is always crucial, using the information below. Now note, in this example, we are calculating the present year's magnetic declination versus the year on the map. As you will extract information, you should note that there is a year on the map and there is your present year. In this case, we are currently in 2014, which will be subtracted from the year on the map. Let's look at what year is given on this map. The information is as follows. 23 degrees, 7. Now, as I've indicated to you, this particular example does not show us 23 degrees 7 minutes. It's actually 23,7 degrees west of true north. The mean annual change is 3 minutes westwards. And of course, the year on the map given is 2002. So let's look at our calculation. My first step is always to determine the number of years, which I will write as follows. Number of years. And what is our number of years? It is equal to the 2014, which is the present year, subtract the year on the map, which is 2002. I get a remainder of 12 years. My next step, the total change. And I'm going to underline these steps so that you don't forget them. The first step is number of years. The second step is total change. Getting back there. And what do I do for total change? I take my mean annual change, which is given as 3 minutes, and multiply that by my number of years, which is calculated to 12 years. And what do I get? That answer that is calculated there is 36 years per minute. Now, as a rule, we should always convert our minutes into degrees and minutes. To do this, I should ask myself, how many times does 60 go into the number of minutes? Why? Because I should remember that 1 degree is equal to 60 minutes. So if I've got 36 minutes, how many degrees is that? The simple question, how many times does 60 go into 36? And my answer, of course, is equal to 0 degrees and 36 minutes. Remember, the moment the answer in minutes is greater than 60, you should always convert that, whether it's higher or lower, to a degree and minute. In this case, my answer calculated was 36 minutes. How many times does 60 go into 36? 0 degrees, and the remainder is 36 minutes. Let's continue with the calculation. Moving further on, now I'm able to calculate the magnetic declination. And note, it is actually for the present year, which I must include, and therefore we go back to my question, and here's my mean annual change given as 23 degrees 7 minutes. 23,7 degrees. I've noted that my mean annual change has been westwards, so I will add. The golden rule is when it's westwards, we add on the step. When it's eastward, we subtract. Let's go further. Plus my 0 degrees, 36 minutes. In this example, the rule is as follows. Whenever you get 23,7, it could be comma 6, it could be comma 5, but the range will be between 1 and 9. In this example, we've got 23,7. The figure immediately after the comma is always multiplied by 6 to convert it to degrees and minutes. So my next step is 23 degrees, and 7 times 6 is 42. 42 minutes. Plus, because it's westwards, 0 degrees and 36 minutes. If moving on further, now I'm able to use my like terms. 23 plus 0 is 23 degrees. 42 plus 36 is 78 minutes. Now, there is a further step. Again, we've got to ask ourselves, 78 minutes. How many degrees in 78 minutes? Obviously, guys, your question, how many times does 60 go into 78? 1 degree, remainder 18 minutes. And what do I do with that degree? I add it to my 23 degrees, and the answer is 24 degrees and 18 minutes. Now, for those of you that are struggling with this calculation, if it's followed through step by step, you should be able to determine what is going on. However, very important, you've got to extract the correct information. How's that going, Tara?
Very well. I'm finding this very interesting, a completely different way of calculating stuff. It's very
Great.
interesting. But no questions from you guys, so please feel free to ask.
Good. And remember, if you extract the correct information, you're going to get it right, because these steps are crucial in ensuring you get the maximum mark. And my final answer is 24 degrees and 18 minutes. Let's move on. We've got some interpretation for you. Now, when it comes to interpretation, your holistic understanding of the entire map has to be brought in order for you to answer these questions. These questions generally require you to bring in your knowledge of general climatology as well as general geomorphology in order to understand and interpret and apply your knowledge onto the map. In this example, again, we've taken out an extract of the map in order for you to be assisted with this calculation. The question reads as follows. Is the aerial cableway station at Trig Beacon 66 in C6 intervisible from the tunnel entrance in D3? In this example, we've got the following. The extract is here, and if you look closely, here is our aerial cableway. The next question gives you, provide a reason for your answer. Now, in this example, you have to understand the term intervisible. Intervisibility is generally tested under landforms and contours. When an object, or in this case, a landform, is intervisible, it means we are able to see in the distance the object. Now, I'm going to draw a sketch before I answer this question for you to have a better understanding. So, let's extend this page for you and understand it as follows. Let's say, for example, this was our landform. And I have the following. Let's draw Tara here.
There we go.
Right, and Tara here. And Tara here. So we've got Tara 1, Tara 2, and Tara 3. In Tara's line of sight, she's able to see 1, but can she see 2? So, Tara 3 and Tara 1 are intervisible, but Tara 3 and Tara 2 are not intervisible. What does this mean? When we're testing visibility, an object or a landform is either intervisible or not intervisible. Intervisible means can be seen through the line of sight. Not intervisible means cannot be seen through the line of sight. Why do we do this? Especially in the construction industry, where we are working with different land surveying methods. Intervisibility comes into play to determine our line of sight in terms of height of buildings. So, when we're testing intervisibility, we've got to look at the contour lines on a map. Because what you should know is that your contour lines give you the height of the landforms. And if you can look at the contour lines and determine how high that particular point is, you will note whether it's intervisible or not. Let's look closely at the map again. Now, looking at the map, the question reads, the cableway at Trig Beacon 66 in C6 from the tunnel at D3. Let's look closely at the map, and what we see is the following. Here's my Trig Beacon 66 at the end of the cableway, and here's my tunnel at Brits. So, if I look between these points, note the following. The contour lines are close together, so that's a steep slope. So I'm going to draw it as I see it. The slope runs up to the top, then runs down. Notice the space in between. Then runs up again and down, and up again and down. Are you noticing how the landform is sketched? It is running through different heights at high intervals and low intervals. This is what we would call a multiple hilled slope. Now, where are my 2 points? My Trig Beacon 66 is at the highest point, but my tunnel is at the lowest point, there. So, is it intervisible or not? In this case, we should say it is not intervisible. Why? The particular multiple hilltops actually obstruct the line of sight between the tunnel and the Trig Beacon. Therefore, the Trig Beacon 66 is not intervisible to the tunnel in this particular area here. Remember, intervisibility will determine whether the site can be seen. Not intervisible, the site cannot be seen. So therefore, we should be able to answer this question because this is a simple concept on topographic maps. What do you think, Tara?
Sounds good to me.
Great. So guys, with that, I want to take you to a break and get back to Tara with that.
Wonderful. During this break, I would urge you guys to have a look at that question, challenge question. We'd love to hear what you think. And post it online so we can see, answer, and have a look at what you've done. But that's it for now, and we'll see you after the break. Welcome back, guys. I'm loving this. I'm getting a few questions. I've got mindsetters on the ball, so it's lovely. I'm so glad to see all of this. I'm going to start off with a question that we got here from one mindsetter, and it's referring to one of the calculations we did earlier. The question is, when calculating the MD, why did we have to multiply the 7 of the 23.7 degrees by 6 in order to get 42? Kamlan, how can we answer this?
Excellent question. And I'm going to take you through an explanation that when it's explained, you're going to see how easy this is. Remember, and I'm going to write this on the board so you don't forget. If we look at our general rules, and I've gone back to the question, and I'm going to write it down here. I've already indicated to you, let's get a pen, 1 degree is equal to 60 minutes. Remember, a degree is like an hour. So 1 hour on my watch is 60 minutes. But if I indicated to you, I've got 0.9 degrees. What do you think this is? 0.9 of 60 minutes, which in this example is equal to 54 minutes. Now, in our example, we've got 0.7, in this case 23.7, which is 0.7 And therefore, to get to that answer, I would be 42. And if I extend my page further, note the following. 0.6 would be 36 minutes. And if I go further down, 0.5 degrees, let's get those degree signs in there, would be 30 minutes. And if I got 0.1 degrees, it would be 6 minutes, wouldn't it? So, in intervals of 6, and this is a simple thing that you've got to understand. In intervals of 6, we multiply each time by the figure after the comma, which is, in this example, comma 7. So, 1/10 of a minute is 0.6. So therefore, in order to calculate any figure after a comma, we need to multiply by 6 to convert it to degrees and minutes. So if my map gives me 0.1, I will note that the answer given is multiplied by 6. What is 1 times 6? 6 minutes. And therefore, as we move up by comma 1, comma 2, comma 3, it would be multiplied by 6 to the point where, in this example, we've got 0.7 degrees, which is converted to 42 minutes. Now, remember, if you think of time, this would be ably understood. Every 6 minutes will be 0.1 degrees. In order for you to get 0.2, you would be working with 6 times 2, which is 12 minutes, up to the point where you've reached 60 minutes, where it becomes a degree. And this is simply the reason why we multiply by 6. I hope, Tara, that gives you some idea.
That makes a little bit more sense to me, but I also want to understand a little bit more as to why magnetic declination is important.
Excellent. Why is it important? Remember, position on the Earth as we move into technology is now becoming more and more important in terms of your exact location in relation to other points on the Earth's surface. Satellite tracking devices can give you your exact coordinates in terms of latitude and longitude. However, what's important is you should always remember that the Earth is a sphere and is geoid in shape. And also, it exists at an inclination. It is not perfectly from north to south. Because of this inclination, which you've studied in grade 8, which is existing at 23.5 degrees, the Earth is slightly tilted. So north is not necessarily north, but the magnetic north. So whenever we are calculating our position is in relation to the North Pole. But the North Pole is not perfectly at the top of the Earth. It is actually at the end of the tilt because of the Earth's tilt. And therefore, the magnetic north is actually where the North Pole is.
Very
and
interesting.
This helps us better understand any point on a map in relation to other points. And magnetic declination helps us calculate that variation.
Very,
How's that,
very
Tara?
interesting. There was a mindsetter that pointed out an incorrect calculation, which I would like us to go to. It was the first calculation that we did at the beginning of the last segment. So let's just have a look at that and see where we went wrong.
And I'll tell you why I went wrong, guys. Because I wasn't using a calculator. And that is key to accuracy. So you've got me there. I wasn't using a calculator, and I relied on my genius calculations, and therefore we slipped up. But let's go back to the calculation, use a calculator, and get the accurate answer. And Tara is going to assist me to ensure that we get the right answer.
Of course.
So let's go back to the question, which was, if I'm not mistaken, the area calculation.
Yes.
In this example, we asked, calculate the area of B1. If you noticed, we've used the formula area is equal to length times breadth. I've measured the distance in millimeters, and I've got 37 for the length, and I've also measured the distance in millimeters, and I've got 31 for the breadth. Note also that my 0.05 is the scale that I'm using in order to ensure that my scales are accurate. When I measure in millimeters, I multiply by 0.05. Herein lies the error. Now, let's look at it. When I calculated this, I had 1.85 kilometers for the length. When I calculated the breadth, I had 1,25. Now, let's go back to the calculator and note the following. 1.85 times 1.25 gives me 2,3125. When we're using a calculator, remember, you've always got to round off to 2 decimal points. So I'm going to take out this final answer. Get back to my calculator, and my answer is 2,31. 2,31 kilometers squared. And with that, guys, remember, don't rely on that mind. Sometimes it's going to go wrong. So you've got to ensure that you're using calculators in order to get the answer right. Happy, Tara?
Very happy. I hope you guys are too. So that's it from me and from the Mindsetters, so we can carry on.
Great. Let's move on to the question on intervisibility. And in order to do that, let's move on from there. We were calculating the intervisibility to the aerial cable. And remember, the answer was not intervisible because our line of sight was obscured. Give a reason for your answer and note the following. Your answer, there are obstructions between the 2 points. And that's better enabling us to understand how we determine the intervisibility. Remember, if you can see between the 2 points and there's no obstructions, then we are intervisible. However, if there's an obstruction between the 2 points, we are not intervisible. This is the golden rule. How's that, Tara? Do you think we should answer the challenge question at this
I
stage?
definitely think we should look at it, yes, yeah.
Okay, so we've asked the question, how many topographical maps will be required to map the entire area of South Africa? What do you think, Tara?
Oh, I'm not going to use my brain because I might go wrong here. I have no idea.
Okay, and
Tell
the
me, show
answer
me.
is, oops, we've got the exam question, but the answer for the topographical maps, remember, is 1,913 maps. So 1:50,000 maps, 1,913 of those cover the entire mapped area of South Africa. You just get one of those 1,913 in an examination. So it would be appropriate for you to collect all those maps and map the entire area of South Africa. So when it comes to exams, you know every possible spot. Let's move on with the questions for the exam. State and give a reason for the direction of flow of the Crocodile River. Now, in this example, like many others, you should be thinking about your geomorphology that you've studied. Direction of flow of rivers is largely determined by the contour lines or any points giving you the heights at particular points on a map. So, when looking at the river, you should consider the following. Here is my Crocodile River, and does not mean to say that I'm drawing the line like this. It is the direction of flow. I'm going to go further in, and when I come here, notice there's a dam, and this is the Hartbeespoort Dam. But in order to determine the direction of flow, I should note the following. Here's particular contour lines, and if I look at it, it's sloping downwards. If I look at those contour lines, it's sloping downwards, which means that the river flows out of the dam. And that direction is determined by drawing a compass at this point. So there's north, there's south, there's west, and there's east. The Crocodile River flows in a northwesterly direction out of the dam. So my answer for this question is northwest. And if you look at it, it's got the question as follows. State and give a reason. Now this is important because there's 1 mark allocated for the direction and 1 mark for the reason. So if I'm looking at this particular map, note the heights are given on this map. And I'm going to take you through a better map in order for you to see this particular example. So let's move the map cursor down there. Right. And here it is. Note the heights at that particular point where the river is. And it captures the entire Hartbeespoort Dam. And you've got the spot heights of 117, 0.7, 1162, which is a benchmark, and 1166.4. Notice the dam wall, which is next to the Brits Tunnel, as well as the river flowing out of the dam. So my possible answer there would be the river flows out of the dam. And I'm going to write that down for you. The river flows out of the dam. Also, we can include another possible answer, the contours decrease in a northwest direction. So guys, this is essentially what has to be captured. Remember, the direction of flow of a river is determined by the heights of the contours or features like a dam wall. Now, a dam wall, from where it begins, the river would flow out. You've got to look at various aspects on a map to determine how the river flows. What do you think, Tara?
You caught me off guard. Sounds good to me.
Great. Now, guys, some last minute tips for you. What I want you to do to get better prepared for your examination in grade 10 is make sure you speak to your grade 12 friends. Obtain their Mapwork papers. Get ready because you're going to be in matric in 2016 and you've got to start practicing your map work. Remember, map work is an integration of grade 10, 11, and grade 12. So you've got to constantly ensure that you're practicing these calculations with a calculator in order to ensure that you are accurate all the time. But more importantly, once you do them in grade 10, you master them in grade 11, you're going to get them right in grade 12. There's various other calculations which we have not touched on, but in future shows, we're going to give you more detailed aspects of interpretation as well as calculations. You have the tools with you. You've got to ensure that you're constantly updating yourself with aspects of different types of topographical maps. The reason for the challenge question is any one of those 1,913 maps can be tested, especially in a Mapwork paper. You've got samples at school. I would advise you always to ensure that you look at these different maps and look at different things like cultivation, as well as different types of excavations and mining areas. This will help you better understand why settlements as well as buildings are located where they are. At a grade 10 level, you've got to ensure that you're constantly bringing in the theory work that you've done in order to integrate it on a map. And with that, Tara, what do you think?
I think geography sounds fascinating. I'm sad I never took it as a subject. There's so much to learn.
There is a lot to learn.
And it's so interesting finding how everything fits and why it works that way. I think it's a science in itself.
It's a science that may not be exactly a science because it integrates humans as well as natural environments to understand why people are the way they are and why they adapt the environment to form a better form of living. So, with that, guys, before I hand over to Tara, I want to say the following. Practice, practice, practice makes you better understand your practical work in Mapwork. All the best for the exams. That's to you, Tara.
Thank you very much. I've had a wonderful time with you guys here today. Before we go, I'd just like to remind you of a couple last-minute things. As I mentioned before, get on to that K53 Be a Bright Spark competition if you're interested in beginning with the process of your learners and your drivers. Such a nifty way to win a car. Chevy Spark, it sounds absolutely incredible. All the information that you need is found on our Facebook page, facebook.com/learn extra. Be sure to like it, and be sure to like the facebook.com/Safeways K53 page. There's so much to get from that information, and please be sure to enter. I think it'll be very beneficial. This was proudly brought to you by the MTN SA Foundation and endorsed by the Department of Basic Education. I've had a wonderful time with you guys and Cumberland today. I learned a lot myself. Thank you very much for joining us today, and I hope to see you soon. All the best for the rest of your exams, grades 10s, and we'll see you soon. Thank you. Bye.